yang recorded yang last week tu saya letak banyak macam kita borak je, tapi it's okay lah kan, asalkan kalau nak tengok balik boleh tengok balik, sebab kadang-kadang kita punya internet ni if you facing any problem nanti boleh tengok balik kan kalau ada yang benda yang kamu tertinggal yang saya cakap. Okay ke macam tu? Okay, so now I will share my Yulen first. Okay. Eh. Search engine. Okay. Okay, I already put today's material inside Yulen. Then there is one R file. Boleh buka ke? Sebab saya tak test download lagi. Okay, this is the last week punya recorded yang saya letak. Nampak kan? Okay, then this is the note for today's. Okay, hari ni quite a long day because we have to finish about 80 slides sampai petang, and there is R code. R code tu dapat download ke? Buka dekat R. If you face any problem, bagi tahu nanti saya bagi link Dropbox saya. Okay, then this is the reference book. Okay, this is the reference book ni kan kita guna untuk hari ni. But if you want to refer to this book, bila kita nak clean data semua kan boleh. Dalam ni ada banyak, okay, introduction to R, creating a data set. Okay, just in case if my notes dekat yang last week tu macam tak berapa nak cukup, we can refer to this book also. Buku ni pun saya dah letak dekat dalam Ulen, so then you can refer to this book. Okay, now let's begin with our kuliah. Sebelum tu ada apa-apa tak?
Kakak ni okey doktor.
Okay. Kalau ada apa-apa soalan ke apa ke, boleh tanya.
Okey.
InsyaAllah kita study sama-sama. Okay, this is the today punya slide. Ada dekat dalam Ulen juga. Okay, for this slide, actually, okay, this is the data analysis and graphic. Yang ni lah Robert Kabakov. This is the book that I mentioned just now, yang I put it in your Ulen just now tu. Ni lah booknya. Okay, analysis of variance. Okay, then we are focusing on analysis also. Previously we learned about multivariate data analysis. Okay, this how we analyze multivariate data. Then today we will focus on analysis of variance, or we call it as ANOVA, analysis of variance. Okay, then the second slide here. Okay, dekat sini. Okay, actually the ayat-ayat ni semua dalam buku tu sebenarnya. Buku ini ialah nota from Dr. Fauzia. He take from the book Kabakov just now. Okay, then can read as an introduction. Yeah. Okay. When factors are included as explanatory variable, our focus usually shift from prediction to understanding group difference, and the methodology is referred to as analysis of variance. Analysis of variance. Variance ni kan apa? Variance. Kalau in term of COVID ni kan kita tengok variance COVID. COVID tu macam dia punya species yang berbeza, right? Variance. We look at the variance, right? the difference. Analysis of variance. Okay. ANOVA methodology is used to analyze wide variety of experimental and quasi-experimental design. Okay, this chapter provides an overview of R function for analyzing common research design. We focus on this slide and then we open our R for the lab. Kita buat inilah secara serentak lah untuk how can we analyze the data using this ANOVA using R. Okay, in addition to base installation, we will be using the car, gplot. Okay, this is the syntax, kita punya apa? Kita guna this function car, gplot, hash, rrconf and mb outlier package in our example. Okay, after this we will use this package in R. Okay, be sure to install them before trying out the sample code. Okay, no need to worry because after this, if we do the lab, then we will install it while we are doing the lab. Okay, and this is the crash course on terminology. Of course, in this statistical, we learn about statistic and a lot terminology. And for this course, okay, for today's course, okay, experimental design in general and analysis of variant in particular has its own language. Okay, before discussing the analysis of this design, we quickly review some important terms. Okay, for this topic, we will use one study. Okay, okay, this is the example for this for this chapter. Okay, say you interested in studying the treatment of anxiety. Okay, then two popular therapy for anxiety are cognitive behavior therapy, CBT. Cognitive, this is the therapy for that anxiety. Okay, and another one is eye movement and desensitization and reprocessing. This is the two therapy for this anxiety. Okay. Then you recruit 10 anxious individual. This is as a sample. Okay, and randomly assign half of them to receive 5 weeks of CBT and half to receive 5 weeks of EMDR. Okay, from this 10, we divide it 5 will receive the CBT therapy and another 5 will receive this EMDR. Okay, then at the conclusion of therapy, each patient is asked to complete the state trait anxiety inventory, which is STAI, and self-report measure of anxiety. Okay, this is the end of the therapy lah to see the effectiveness. Okay, then in this design, treatment is between two group factor is two level. Okay, just now we have 10 person, right? Then we divide this 10 person, 5 will receive the CBT treatment and another 5 will receive the EMDR treatment, and these two group will do the STAI assessment and the just now the another one is self assessment. Okay, self assessment. Okay, this is the summarize of this study. Okay, then okay, in this design, treatment is a between group factor with two level. Okay, between group. Okay, this is two group and receive this different treatment. We call it as between group factor. Between group factor with two levels, CBTR and EMDR. It is called a between group factor because patients are assigned to one and only one group. Okay, this is what the meaning of between group factor. Okay, No patient receive both, okay, EMDR and CBT, and the S character represent the subject patients, okay. And STAI is the dependent variable and the treatment is the independent variable. Okay, okay. You know it, you notice that? Okay, STAI, this is the dependent variable. Why? It is depend on the treatment CBT and EMDR. And this is as our independent. It not depend on any variable. Okay. Faham? Independent dengan dependent ni ingat lagi tak apa dia? Kalau kita ada graph kan? X and this is Y. Yang mana satu independent, yang mana satu dependent?
Lalunya X dependent kan?
Dependent. Dependent ialah dia bergantung kepada, dia depend. Dia bergantung kepada satu. Dependent. Kalau independent tidak bergantung, right? Yang ni yang bebas, dia macam free. Kalau kita ada if we have like this table, before we want to do the graph, we have the value inside the table, right? Kita ada X value and Y value. For example, kalau sekarang ni musim banjir kan? We have the contoh we have the X ni ialah date, hari. And we have the Y value is ml je. Berapa isi padu air yang turun hari hujan, contoh isi padu kan. Kalau isi padu ml kuasa 3 isi padu hujan yang turun tu. Okay, then which one is independent in this data? Ingat balik.
Date.
Betul. Jadi kat sini kita nampak tak CBT dengan EMDR ni is independent sebab kita dapat value ni, kita terus je buat dekat orang, we just do a therapy for these 5 different person. Dia tak bersangkut dengan apa-apa. But this assessment for STI and SE is depend on these two result. Jadinya so this is independent and this is dependent, right? Itu sebab dia kata SEI ialah dependent and the treatment is the independent. We can do treatment without knowing any data, which is we only have the sample, then we can do the treatment. Macam itulah, dia tak bergantung pun dengan apa-apa. Yang table and this graph ni nak ingat balik what is dependent and what is independent. Okay tak?
Okay, Doktor.
Okay, because there are an equal number of observation in each treatment condition, you have balanced design. Okay, what balanced design? Because equal number of observation, we have to observe from these 5 and these 5. This is what we call balanced design. Okay, when the sample size are unequal, meaning that, okay, 5 ni is our sample size. Kan, yang 10 ni, we divide it 5 dengan 5, which is, it is equal. Kalau, if, for example, if we put it this as a 2 and this treatment to receive this treatment as an 8, okay, this is unequal, kan? Which is we have unbalanced design. Ini kita nak faham dia punya terminologi je dulu. What is dependent, what is independent, what is between group factor. Okay, harap faham Dah faham lah. Inilah yang penting dekat slide ni. Okay, can we move? Okay, then statistical design in table 9.1 is called Way Anova because there are single classification variable. Okay, look at 9.1 table. Okay, this is the table 9.1. Okay, one way between group ANOVA. Okay, this is one way between group. Okay, between this group, these two group. This is one way. Okay. Just now dia punya ayat ialah apa? It's called one-way ANOVA because there are single classification variable. Okay. Specifically, it is a one-way between group ANOVA. Okay. In fact, in ANOVA design primarily evaluated through F-test. Okay, nanti kita rasanya saya ada letak. Okay, kalau nak baca what is F-test in statistic, you can look at this link. Saya dah letak dekat dalam slide tu. Kadang-kadang kita tengok balik nota dulu. Dia belajar tak? Aku rasa.
F-test saya rasa macam tak pernah belajar.
Tak apa.
Tapi
Kita
ANOVA
tengok.
ada lah.
ANOVA
Z,
ada.
Z-test kot, tak silap saya.
Okay.
F test tu F1 score tu ke?
Tu lain.
F1 score tu yang kalau kita nak tengok accuracy F1 score itu kan?
Itu TP true positif, true negatif tu kan.
Okay.
F-test tak pernah.
Boleh tengok kat sini. Nanti what is F statistic. Okay. Kat sini ada video. Nanti boleh tengok Okay, I'll put the link here. Kalau kita study pun kadang-kadang kan ada benda, kadang-kadang kita dah belajar tapi kita lupa. Lepas tu ada benda yang kita tak belajar, then you have to search for it. Kan? Kita dah banyak e-book, kita dah banyak, we have internet source kan. We just put it, the keyword, then we can receive the information. Jangan, we don't let it macam, okay nantilah tahu, kalau macam kita nak belajar, we have the what we call kita sifat nak tahu tu kan. Okay, this is, okay, dia macam significant test jugalah. Okay, using the F statistic, you're doing support to reject null hypothesis. If F test result, you have both value and critical value. Okay, then ini dia macam, yang berkait dengan yang null hypothesis yang last week tu, how can we decide something? This is F test ni lah. Okay, then you can find, boleh baca Dia kena
Boleh, Doktor.
dengan p-value tu, nanti tengok kat sini, you can follow this note. Okay, F value in regression, how they conclude something by using the F value, and there is YouTube video also here. Okay, then we go back to our note. Okay, and this is just now. Okay, nampak ke? Sekejap saya share. Okay, yang tadi tu dia kata look at the 9.1 tu. Okay, this is the table for one-way ANOVA because there is single classification variable. Okay, this is one way between group ANOVA and okay, effect in design are primarily through F-test. F-test just now, please look back at the information. If the F-test for treatment is significant, you can conclude that the mean, okay, STI score for two therapies differed after 5 weeks of treatment. Okay. F-test for treatment is significant. You can conclude that the mean STI score for the two therapy differed after 5 weeks of treatment. Okay, then kat sini, if you are interested in the effect of CBT, contohnya kita nak fokus kan dekat CBT je. Justnya CBT tu ialah kita punya treatment tu. Okay, on anxiety, over time you can place ke semua yang CBT selepas kamu dapat result ni, contohnya you want to focus on CBT only, okay, then you can find by place all 10 patient tu dekat CBT group and assess them at the conclusion of therapy and again 6 months later. Maksudnya kita nak tengok dia punya guna CBT punya treatment. Just now kita ambil dia punya treatment tu sebanyak 5 minggu je. Okay, lepas yang 5 minggu tu we get the F-test treatment significant, and after we get the F-test significant tu, we conclude something, then we want to we interested in the effect of CBT only. Okay, kita boleh buatlah CBT tu, tapi kita guna 10 patient, all the patient, then we do it again in 6 months later. Maksudnya macam ni. First yang tadi tu kan kita guna treatment, we divide it into 2 group, which is 5% will receive CBT and 5% will receive EMDR. This is within the 5 week. Then after we get the F-test score, we want to focus on CBT only. Then the result for the 5 week, we go for the all the patient we do it therapy for the CBT, then we get the result for the 6 month. Macam yang ni kita namakan dia sebagai apa? Okay, this is one way within group ANOVA. This is the only one group, kita groupkan satu, tapi it is one way within group ANOVA. This is between group. Ini ialah between group. Apa yang dikatakan between group tu contohnya seperti table 9.1, and this is one way within group ANOVA. Okay, boleh. Okay, this is time is a within group factor with 2 level. Okay, this is time within group factor with 2 level, which is the level 1, which is 5 week, and the level 2 is 6 months. Okay, it is called a within group factor because each patient is measured under both level. We call it as one way within group ANOVA. Because each subject is measured more than once, the design is also called repeated measure. Okay. Boleh faham ayat ni? Because we repeat after 6 months on the same sample, we call it as repeated measure ANOVA. Okay, if the F-test for time is significant, you can conclude that patient mean STI score change between 5 week and 6 month. Okay, kalau kita dapat F-test result ni significant, which is what is significant, which is the p-value dia less than it is less than p-value, right? P-value contohnya p-value kita setkan 0.05, then if it is less than p-value, then we can conclude something. Which is kita tahu there is change between 5 week and 6 month punya treatment. Kita nak tengok the effect of the treatment kan. Maksudnya kat situ dia ada changes ke tidak. Okay. Then we go for the next slide. Okay, if you are interested in both treatment different, okay, kita nak tengok both treatment different. Lepas tu we want to see the change also. We want to know the difference between CBT and EMDR tu. And another one thing that we want to focus ialah time. Adakah time tu mempengaruhi, and adakah the different treatment tu mempengaruhi. Okay. Actually, if we have data, for example, data hujan kan, adakah we want to know whether the faktor hujan ke, maksudnya adakah suhu tu mempengaruhi ataupun macam mana? Yang tu kan kita as orang yang design the experiment, we have to know what we want to focus. Okay, for this case, they want us if you interested. Okay, maksudnya kita nak tahu is there any different for the treatment tu punya result, and is there any change over time? Okay, then you can combine these two study design and randomly assign 5 patients to CBT and 5 patients to EMDR. Okay, then assess their STI result at the end of therapy 5 week and 6 week. Maksudnya kita dah tak buat macam ni. Okay, instead of we are using this is CBT only, but we do 2 treatment. We want to see the difference between 2 treatment within over time. Macam tu. Okay. By including both therapy and time as a factors, you are able to examine the impact of therapy across time. This is the one result you can able to get. Then the second result is time average across therapy. Kita nak tahu which therapy punya impact tu kan. Okay, jadi kita dapat another one is time impact. First is impact of therapy itself over across the time, and then the second one is time average across therapy, and the third one the result that we can examine ialah the interaction between therapy and time. Okay, for example, if you want to measure which therapy yang ambil less time ke, macam tu, this is the interaction between therapy and time. Okay, the first two are called the main effect. Okay, this is therapy over time, and time tu kita cakap this is the main effect yang kita nak tengok, whereas the interaction ni between therapy and time ni is called the interaction effect. Okay, then okay, yang tu kan sebenarnya table dia macam ni. Okay, this is the two different therapy, and we want to examine CBT over time, EMDR over time, and this time over average of different therapy. Then the interaction between time and CBT and EMDR, that 3 things that we want to examine. Okay, then when you cross 2 or more factor, you have done here, you have a factorial ANOVA design. This is what we call the factorial ANOVA design. When you cross 2 or more factor, maksudnya bila dah lebih daripada satu faktor, macam mana nak tahu faktor tu, ialah kita nak tengok, this is we as a the one who want to analyze the data, we have to examine, we have to determine which impact we want to examine. Contohnya kat sini dia dah beberapa, dia ada 3 kan, 3 faktor yang kita nak tengok. Pertama, kedua dan ketiga. And this is what we call you have factorial ANOVA design. Okay, crossing 2 factor produce. Okay, bila kita ada 2 factor, we produce a 2-way ANOVA. Crossing 3 factor produce 3-way ANOVA, and kalau ada 4 factor, which is 4-way ANOVA, and so forth. Okay, when a factorial design include both between group and within group is called mixed model ANOVA. Okay, yang ni ialah mixed model ni ialah bila kita punya factorial tu, kita nak tengok between group tu yang tadi, yang macam ni between group, which is kita nak tengok, okay, yang ni between group kita dah berbeza kan. But if you want to focus, kalau ada factor yang kita nak tengok within group, this is what we call the mixed mode. Mana mixed mode tadi, ayat tadi? Mixed model ANOVA. The current design is a 2-way mixed model factorial ANOVA. Sekarang ni kita dalam mixed model factorial ANOVA. Kenapa mixed model? Dekat mana yang within group? Within group. Kalau between group yang dekat terapi ni, betul tak? Dekat terapi ni. Tapi for the time tu kita ambil semua tu kan sama on a 5 week, it is what we call within group. Macam tu. This is the current design. Kita punya design sekarang ni is two-way mixed model factorial ANOVA. Okay. Okay. Dia banyak ayat tau. Different when we teach kalau calculus ke linear algebra kan kita dapat nombor. This is the subject that we have to understand the sentence. Jadi saya pun kena banyak bercakap lah kat sini. Okay, setakat ni okay ya. Then, in this case, you have 3F test. Bila kita ada impact-impact yang kita nak tengok tu, yang kita nak tahu signifikan ke tidak, kita kena tahu yang kita ada berapa assessment yang kita kena buat. So kat sini kita ada F test, which is dekat faktor-faktor semua tu we have to do a F test. Tadi faktor kita yang mana? Okay, yang mana yang tadi? Which is one is the dia banyak kan. One is the therapy and one for the time. And another one tu yang dia interaction between time and therapy tu. Interaction tu. Okay, so kita tahu bahawa kita kena buat 3F test kat situ. We want to know the significance. Okay, then a significant result for therapy indicate that CBT and EMDR differ in their impact on anxiety. Okay, this is the significant result kalau kita tengok dekat terapi punya F-test. Okay, this is the result yang kita nak tahu. Indicate that differ in their impact on anxiety. Okay, then a significant result for time. Time ni pula ialah dia mencerminkan that anxiety change from week 5 to 6 month follow up. Ini ialah the significant punya indication. Dia mencerminkan apa. Then another F-test punya result nanti ialah another one is a significant therapy versus time interaction. Which is it is indicate that a treatment for anxiety had different impact over time. That is in the change of anxiety from 5 week to 6 months was different for two treatment. Yang ni kita nak tahu dia punya significant. From the interaction, therapy versus time. Okay, then we have these three significant yang kita nak tengok nanti. Okay, lepas ni kita akan dapat, kita ada satu data set nanti, kita akan tengok dia punya test-test semua. Dia signifikan. Nanti kita cuba relatekan dengan apa yang kita punya yang awal-awal punya lecture ni. Okay. Then ini ialah sebenarnya dalam definition lagi. Kita nak faham the terminology, the term semua. Okay, this is what we call two-way factorial ANOVA with one between group. Okay, this is between group CBT and EMDR between group. And one within group factor. This is the one within group factor yang ni. Sebab kita overtime ni kita ambil untuk keseluruhan tu kan. Kita lihat this is within group factor. Okay. 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 It is okay if you are lost ke, sebab it is the challenge for the study online punya study kan, betul tak? If you are in the class also, if we focus on the lecture, ada kadang-kadang kita tertinggal kan, kita macam ada sekali-sekala we macam terlost kan. It's okay. That's why I put in the YouTube, then you can view it again after this. Okay. Then we focus on the slide number 13. Okay. If you want to break, please let me know tau. Tapi nanti kejap lagi pukul 10 kita break kejap ya. Okay. Now let's extend the design a bit. Okay, from this design, we have this design, we want to extend it. Okay, and it's known that depression can have an impact on therapy and that depression and anxiety often co-occur. Okay, then even though subjects were randomly assigned to the treatment condition, it is possible the two therapy group differed in patient depression level at the initiation of the study. We want to know the level pula, depression level at the initiation of the study. Ni kita nak tahu. Okay. Any post therapy, we want to do a post therapy, different might be then be due to the pre-existing depression difference. Okay, the post therapy difference and not to your experimental manipulation. Okay, because depression could also explain the group different on the dependent variable, it is a co-founding factor. Okay, this is what we call a co-founding factor. And because you are not interested in depression, it's called a nuisance variable. Okay, in depression. Okay, then if you record depression level using, okay, then we want to know their level. Ni dah kita extend kita punya eksperimen tau. We want to know the depression level tu. Sekarang ni kita guna self-report depression, self-report depression. Just now kan kita we do a therapy, we doing different therapy within 5 weeks, then we doing after the 6 months, then this is the we extended a bit, which is we want to know the depression level. Okay, depression level ni kita tak guna yang terapi tadi, tapi kita our sample, we are using a self-report depression sebab kita we want to measure their level of depression. Okay, such as the back depression inventory. Okay, this is the one of the self-report depression, which is back depression inventory. When patients were recruited, you could statistically adjust for any treatment group difference in depression before assessing the impact of the therapy. Okay, in this case, this BDI ni is called covariate. And the design would be called an analysis of covariate. Okay, lepas kita, yang ni macam ni tau. We want to know we want to know their level. Lepas tahu dia punya level, baru kita bagi dia punya apa? Which therapy yang dia perlu pergi. Okay, yang ni analisis yang macam ni kita panggil dia sebagai analysis of covariant. Okay. Previously on the previous slide, previous class, we learned about variant. What is variant? But here, if you want to know what is covariant definition, you can see from this link. Okay. Kita boleh tengok kat sini. Kita boleh tengok. Okay. What is covariant tu?
Doktor kata analysis of covariance ni untuk tahu dia dapat treatment macam mana tadi ayat doktor?
Dia macam kita nak tahu dia punya depression level tu. Kita extend a bit sebab kita if we already know their level, then we can go for the therapy mana dia nak pergi.
Oh, okay,
Macam tu, kita extend a bit. Sebab previously kita tak ambil tahu pun dia punya level, betul tak? Then this is the time we want to know. Okay, adakah different level ni kan ada impact tak untuk the different therapy tu? Nanti kita dapat another result pula kat situ. Kita nak, sebelum kita assign tu kita dah tahu dah. Dah tengok dia punya impact different level on the different therapy. Okay.
Okay.
Okay. Then lepas kita dapat yang dia punya different level on different therapy tu, baru kita record back the single dependent variable in this study to the STI punya assessment yang last tadi tu, nak tahu dia kita punya keputusan. Macam tu. Dia macam kiranya dia macam ada dua lah. Okay, previously kita previously kita tak measure pun dia punya different depression level. Lepas tu tapi yang ni kita extend pula kita punya study, adakah level of depression ni on the each therapy that they have terapi yang dia buat tu adakah memberi impact ke tidak. So kita nak tahu, so kita buatlah STI yang last tu, yang dekat ni, dekat dependent variable yang tadi tu, STI tu. So kita tahu dia nanti daripada result tu nanti kita tahu adakah apa impactnya. Okay. You could increase the validity of this study by including additional measure of anxiety. Okay, for example, okay, yang ni kita boleh tambah lagi untuk kita punya study ni. Mula-mula kita go for each treatment therapy. Yang ni kita grow kita punya experimental, kan, betul tak? Then this is kita measure anxiety such as family rating, therapist rating. Okay, kat situ. Kita buat satu assessment pula daripada therapist rating and a measure assessing impact of anxiety of their daily functioning. Okay, ni kita buat pula satu macam questionnaire, survey. Kita nak tahu dia from the family rating, then therapist rating. Kadang-kadang terapis tu, terapi yang treatment tu okay, but in term of orang yang bagi terapi tu pun kita nak tahu juga impact dia, orang yang macam mana, kan. Adakah dia jalankan session yang perlukan ada session one to one dengan terapis tu berjalan dengan baik ke tidak. That's the impact. Yang lagi satu lah, validity of this study pun kita nak kena tengok juga. Okay. Okay. When there more than one dependent variable, okay, lebih daripada satu dependent variable, the design is called multivariate analysis of variance. Lebih daripada satu dependent variable. Ini kita kata sebagai MANOVA. Okay. Yang tadi kan contohnya kita ada satu dependent iaitu STAI tu, kan, betul tak? Yang STAI ni dependent variable kita. Dia bergantung kepada terapi yang CBI dengan apa? Yang tu kan, terapi yang berbeza tu, kan. Okay, another one yang self dependent tadi tu. Self assessment tu. Okay, yang ni kita panggil dia sebagai, bila dia dah ada more than one dependent variable, the design is called multivariate analysis of variance, which is MANOVA. Okay, if there are covariate present, it's called a multivariate analysis of covariant, MANCOVA pula. Ni semua term lah ni. Okay, what is MANCOVA ni? Saya ada letak notes kat bawah ni, nanti tengok tau.
Okay, doktor.
Okay. Then we go for fitting ANOVA model. Okay. Then although ANOVA and regression methodologies developed separately functioning, there are both special cases of the general linear model. Okay. Linear model. Linear model tahu, kan? It is garis lurus lah. Kita nak modelkan satu-satu regression tu dengan menggunakan garis lurus. So we could analyze ANOVA model using the same linear model punya function dekat dalam R, LM. Yang bracket ni ialah linear model function. Use the for regression. Okay, this is chapter 7 ni, dia refer kepada buku yang tadi tu lah yang saya letak dekat dalam Newland tu. Regression, ada regression dalam tu. Okay, however, we'll primarily use the AOF. Sebelum terlupa, kat sini ada orang Selangor ke? Selangor ke, Pahang ke? Banjir kan? Anis dekat Negeri Sembilan tak banjir?
Oh, tak. Tak ada orang Selangor.
Afrika?
Dia orang Johor semua.
Wah, tak banjir kan? Adibah kan?
Alhamdulillah.
Dia
Alhamdulillah.
orang Melaka tapi family saya ada dekat Kelang dan banjir.
Adibah maksudnya Adibah duduk dekat hostel lah ni? Ke bukan?
Tak, maksud saya macam relatif saya banyak dekat Miru, kampung
Oh,
saya.
okay.
So banjir lah. Saya duduk Melaka. So tak effect lah.
Tak effect kan?
Hmm.
Kan kat diorang semalam saya balik kampung dekat Selangor. Balik Batang Kali banyak jalan tutup.
Sebenarnya saya pun nak balik juga minggu ni. Tapi macam diorang kata jangan balik sebab takut banjir. Lepas tu memang betul-betul banjir. So saya cancel lah balik.
Betul lah. Saya tak tahu pun ada banjir ke tidak. Hari Sabtu tu balik kampung sebab mak saya stroke. Memang bedridden lah. Memang gantikan kakak. Lepas tu saya saya kan lalu kat Gatri tu. Masa saya lalu tu jalan yang nak ke Shah Alam tu dah tutup.
Shah Alam banyak tutup. Ya.
Nampaklah air naik. Rupanya yang lepas saya lalu tu yang Lagong apa semua Elmina apa yang jalan nak pergi Lata tu rupanya tutup. Lepas tu Alhamdulillah maksudnya air naik dengan cepat kan. Masa saya lalu tu belum lagi. Tak ada apa-apa tapi tengah hujan lebat lah. Saya pukul 12 lebih tapi Alhamdulillah dah saya sampai rumah. Lepas tu baru saya nampak ada news lah kata Gatri tutup sebenarnya. Alhamdulillah saya dah terlepas. Kalau tidak
Kawan
memang
saya
saya
banyak start dekat stranded dekat Bukit Jelutong. Dia macam satu malam dekat atas jalan. Ramai lah.
betul, dia ada macam bila kita lalu tu mula dia tak ada apa-apa tau. Bila dia macam dia naik dengan cepat. Jadi orang yang dah ada dekat situ tak boleh nak ke mana-mana kan?
Betul. Kesian sebab dia orang lapar satu malam kan. Saya macam aduh, kesian betul.
Yelah kalau orang balik kerja, orang baru lepas apa mana ada makanan apa kita bawa kan? Memang tak ada lah kan?
Betul.
Betul sangat.
Dia nak jadi.
Benda nak jadi kan? Kalau kat situ dah lah kalau orang kata boleh tidur hotel ke apa. Kat situ tak ada kan?
Jalan memang betul-betul jalan.
Atas jalan kan? Mana nak cari hotel? Tak ada.
Itulah.
Itulah. Benda nak jadi kan? Alhamdulillah tak ada apa-apa. Okay.
Alhamdulillah.
Alhamdulillah. Okay, so kita sambung. Dia macam commercial break. Okay, so sekarang ni kan kita nak masuk dekat macam mana kita gunakan yang tadi yang kita belajar terminologi apa semua yang F-test apa semua tu kan significant ke tak significant tu. We want to do it using R. Okay, so this is the function that we use lah. We want to build a model which is, just now kita tak belajar pun pasal linear model ni. But this is how we model our regression. Okay, by using the linear model. Okay. And however, we primarily use AOV function in this chapter, which is analysis of variance. Untuk yang ni, we are using this fungsi. Okay. Then the result of this LM and AOV ni are equivalent, but the AOV function present this result in a format more familiar to ANOVA methodology. Okay, maksudnya sekarang bila kita guna linear model punya function dengan AOV ni jawapannya sama. Tetapi kalau kita nak guna analysis, kita nak buat analysis of variance, okay, we are better using AOV punya fungsi. Okay. For completeness, an example using LM at the end of this chapter is also provided. Okay, but here we are focusing on analysis of variance punya example. Okay. And this is the AOV function tu lah. This is the syntax. When we are using R, AOV, then this is the formula that we will use. And what is the data? Data frame tu. Contohnya kalau kita guna, we have to we have to get a data to analyze kan, mestilah ada data. Ini maksudnya data frame ni whether it is dalam bentuk XLS ke, RDS.RDS ke, ataupun CSV ke, the data frame yang kita ada lah. And this is the formula. Okay, then table 9.4. Okay, 9.4 ni describe special symbol that can be used in the formula. When we want to build a formula, we have to use a specific symbol, and this symbol we can find it in table 9.4. In this table, y is the dependent variable and the letter A, B and C is represent a factor. Macam tadi, cuba relatekan apa yang kita belajar awal-awal tadi. Dependent variable dia ialah Y ni, the STAI, maksudnya tadi yang assessment yang STAI tu, then the letter A, B, C represent a factor. Just now yang kita contoh kita on anxiety just now, the factor which is A ni contohnya is on the therapy, B is on the time and C interaction between therapy and time. Okay, yang tu lah maksudnya reflect kita back apa yang contoh yang kita dah buat tadi. Okay, then this is the special symbol. This is the symbol for separate response variable on the left. Okay, for example, prediction Y from A and B will be coded. Kita nak tahu a prediction of Y daripada factor A, B, C. Kita boleh code dia sebagai yang ini. And this is separate explanatory variable by using the symbol plus. Then double dot ni denote an interaction between A prediction Y, A, B and the interaction between A, B will be recorded. Ni macam kita punya faktor tadi, which is A is our therapy, B is time, then interaction between therapy and time tu kita boleh letak dia sebagai yang ni. So kita tahu apa yang kita nak tengok kan kat situ. Okay, then multiplication punya simbol ni, yang ni star ni denote the complete crossing variable. The code A times B times C expand to the, okay, maksud A times B times C ni ialah kita nak tengok multiple crossing variable, which is kita macam ni juga. Okay, contohnya yang macam ni kan. Okay, kalau ni denote the complete crossing variable. Okay, maksudnya apa yang dimasukkan yang ni ialah bila kita expand tu kita nak cari A, faktor B, faktor C and the interaction between AB, AC, BC and these three. Okay. And for the power ni, denote the crossing to a specific degree. For example, if we do it A, B, C power of 2, expand to the, apa yang kita nak cari dekat sini is the impact for the factor A, B, C, then A, B, A, C, and A plus A, B, A, C. Yang ni kena tengok balik. Rasanya dah ada kan? Ke BC? Sekejap, kuasa 2. Sebab ni macam dia AB, AC, AB. Crossing specific degree. Okay, ni kita boleh check balik lah, kita tengok. Okay, a placeholder for all variable in the data frame except the dependent variable. For example, if a data frame contain the variable Y, A, B, C, then the code will be this. A placeholder. Maksudnya kita letak dot je. Maksudnya kita sebenarnya kita nak cari Y. Maksudnya kita nak predict Y on the factor of A plus B plus C. Contohnya kan ni kan, kalau kita yang pertama ni kita letak dot je. Maksudnya kita nak cari A, B dan C. Tambah. And this is one-way ANOVA, which is one-way, one part factor kan. Okay, this is one-way ANCOVA with one covariate. Dia ada satu covariate sebelum tu. Okay. Kita nak reflect balik, maksudnya one covariate ni. Maksudnya kita nak tahu different level just now menggunakan terapi contoh. Okay, this is the two-way factorial Ankova. Two-way because of there is two factor A and B. Okay, yang ni pula which is two-way factorial Ankova with two covariate yang ni. Different level. Kita sebelum tu kita nak tahu the impact of level punya depression level ke, tak pun kita nak tahu the impact of the age kan, macam tu. Kita nak tahu different age tu ada tak memberi different apa. Okay, this is what we call contoh untuk two-way factorial Ankova with two covariate. And randomized block. This is the randomized blocking factor and one way within group Ankova. Okay, within group error subject divided by A. And repeated measure. Repeated measure with one within group factor W and one between factor. Okay, yang ni kita takkan tengok kejap lagi. Bila masa yang kita guna formula-formula ni. Okay. Okay. We have the order of formula term. Okay, sebelum kita nak masuk formula, lepas tu kita nak tahu order count ni semua, kita break dulu lah. Kita berhenti dekat slide number 20. We break about 10 minutes. Okay. Okay.
Okay, doktor.
Pause here, then record. Okay, kita sambung ya. The order in which the effect appear in formula matter when, okay, this is effect kita punya order tu nanti bila pertama where the more than one factor and the design is unbalanced, and B ialah covariate are present. When either of these two conditions is present, the variable on the right side of equation will be correlated with each other. Okay, in this case, no unambiguous way to divide up their impact on the dependent variable. Okay. Maksudnya macam mana ni? Macam kita buat formula lah. Dekat mana yang kita nak fokus dulu. Macam kita kalau we have the equation like macam dulu bila kita nak buat manipulation of equation kan kita selesaikan dalam kurungan dulu. Lepas dalam kurungan kita tengok ada darab ke, ada bahagi ke, dan barulah kita selesaikan untuk tambah dan tolak. Macam itulah. Then the formula tadi tu order dia, then they will focus on the ni. A is if there is more one factor, lepas tu the design is balanced or not, then after that barulah dia tackle about covariate. Macam tu the order. This is the first one, then this is the second order yang dia tackle. Macam kita buat yang mana satu yang kita letak dulu. Okay, when either of these two conditions is present, the variable on the right side of the equation will correlated with each other. In this case, there are no ambiguous way to divide up their impact on the dependent variable. Okay, then for 21, slide 21. Okay, for example, in two-way ANOVA, with unequal number of observation in the treatment condition, the model is Y is equal to A times B will not produce the same result as the model Y B times A. Okay. Boleh faham tak? Maksudnya dia takkan sama. A times B ni takkan sama dengan dia punya impact untuk B times A. Okay, by default, R employ the type 1 sequential approach to calculating ANOVA effect. Okay, the first model can be write out as, okay, this is the first model, then the resulting on the table. Okay, for example, if we have model like this, we have A, which is we have the factor A, factor B, and interaction between A and B. Okay, so sekarang result on our ANOVA nanti dia ada berapa? Maksudnya dia ada 3 lah, which is impact A on Y and impact B on Y, and then interaction between A, B, controlling for the AB main effect. Okay, this is the third result yang kita nampak, yang kita boleh access. Okay, nanti. Okay, boleh. Kalau
Boleh doktor.
okay. Alhamdulillah. Kalau kita tengok tadi kita punya impact tu, contohnya A ni ialah terapi, B tu ialah masa, dan interaction between terapi dengan masa, nanti kita akan dapat 3 lah kita punya result by using this model. Itu sebab when we are creating, when we analyze the data, we have to know how many factor. Lepas we know how many factor, then we can write our model. Y ni nak predict untuk apa contohnya. Okay, so then kita akan dapat dia punya result. We have to identify first. Okay, order count. When independent variables are correlated with each other or with covariate, there are no ambiguous method for assessing the independent contribution of this variable of the dependent variable. Consider the unbalanced two-way factorial design with factor A and B and dependent is Y. Then there are 3 effects in this design, which is A, B is main effect, and this is A times B is the interaction. Okay, then we assuming that our model like this, the formula dia macam ni. Okay, there are 3 typical approach for partitioning the variance in Y among the effect on the right side of this equation. Okay, yang macam tadi tu lah, which is impact of A on Y, B on Y, then interaction between these two, which is we have 3 typical approach. Okay, then here, okay, the greater the imbalance in sample size, the greater the impact that the order of the term will have on the result. Okay, maksudnya dia berkadar langsung, which is bila sample size tu semakin besar, maksudnya the impact will be greater also. In general, more fundamental effects should be listed earlier in the formula. Okay, in particular, covariate should be listed first, followed by 2 main effect, followed by 2 interaction, followed by 3-way interaction. Okay, sebab tu bila kita tengok tadi formula tu, mula-mula dia letak covariate. Lepas tu kita letak main effect. After the main effect is the interaction. Okay, interaction. Mula-mula 2-way interaction, lepas tu 3-way. Kalau kita nak tengok balik, if you want to look at the formula back, for example, like macam ni. Okay, contohnya this is the main effect dia yang ni, A, B, C ni. Lepas tu ialah interaction between this 2-way and this is the 3-way punya interaction. Okay, kalau ada, if there is covariate, kalau kita tengok contoh contohnya if it is involve covariate, maksudnya covariate letak covariate dulu, lepas tu baru letak faktor. Macam tu kita susun our order kat sini. Assuming, okay, this is the one just now. Okay, this is the covariate first, lepas tu followed by effect kita. Yang covariate ni yang tadi tu dia wakilkan sebagai X1, X2, then followed by 2 main effect, A plus B plus C for example, and then there is 2-way which is A double dot B. or A for the three-way ialah A double dot D double dot okay, for main effect, more fundamental variables should be listed first. Okay, gender will be listed before treatment. Okay, maksudnya kat sini, even though it is main effect, lebih fundamental variable tu lebih, maksudnya asas, variable asas sepatutnya diletak dahulu. For example, yang asas which is gender dengan treatment. Yang lebih asas ialah gender tu, betul tak? So that we list for the treatment. Okay, here the bottom line, when the research design isn't orthogonal, that is when the factor or covariate are correlated. Be careful when specifying the order of effect. Okay, ni kena take note lah. Then this is okay. Yang ni kita nak cuba buat lab dekat R. Okay. Then dekat sini dah download dah saya punya yang R punya code tu. Kalau dah download, buka lab Anova tu kan.
Dia cuma hanya skrip je doktor.
Script je.
Okay.
Sebab dia punya penerangan tu dekat dalam slide tu.
Okay.
And it's also same with the book. Sama je dengan buku tu. Kita follow sama je. All the explanation inside the slide. If you want to know the further explanation, you can see the book that I attached to. On the chapter 9, analysis of variance, from page berapa? 219 tu. Analysis of variance dekat buku tu. If you want to know further explanation. Kalau macam dekat slide tu rasa macam tak faham je kan what it mean, you can go for the chapter part 3, chapter 9, analysis of variance, page 219. Then kita tengok kat situ ya. Dah buka dah R. Okay, so sekarang saya share saya punya R lah. Nampak R saya. So kat situ kita ada lab Anova version 3.R tu lah kan, Anova. Then run one by one ni. Okay, sebelum tu kita tengok, okay, dekat sini kita akan guna table ni throughout the process. Apa yang dimaksudkan test-test yang setiap satu yang kita belajar tadi tu, kita akan tengok satu-satu. Okay, in one way Anova, nampak slide saya? Saya sekejap pergi kat slide, sekejap pergi kat R. Dua-dua nampak Sekarang saya kat slide.
Nampak.
Hanya nampak slide.
Slide dulu. Nanti sekejap In one way Anova, you are interested in comparing the dependent variable means of two or more group defined by categorical group factor. One way Anova. Remember back, the one way Anova, we have a group factor, which is factor. We have factor, one factor only, right? One way Anova. Okay, for example, come from cholesterol data set. Okay, this is the cholesterol data set that we want to use. Okay, 50 patients receive one of 5 cholesterol reducing drug regimen. Which is TRT tu. 3 of the treatment condition involve the same drug administered as to 20 mg once per day, which is one time. Yang dia tulis one time tu. 10 mg twice per day, 2 times. Then 5 mg 4 times per day. Okay, maksudnya if the times dia ambil tu banyak, the value of the drug tu dia semakin kecil lah. Kat sini tengok dia punya relation kan. Okey, kalau dia ambil sekali saja dia 20 gram. Kalau dia ambil 2 kali, maksudnya the total for the 1 day tu still 20 milligram. Okay, we want to know the effect itulah. Okay, the two remaining condition which is drug. Drug D and drug E represent competing drug. Kita nak tahu drug apa yang terlibat, which is drug D and drug E. Which drug regimen produce the greatest cholesterol reduction response? The analysis is provided in the following listing. Okay, for this lab, okay, try to run. Nanti kita akan dapat table ni lah. Okay, kita tengok dulu ya. Dekat dalam R tu. Okay. Yang kat sini lah sampai kat situ. Fit model cholesterol. Okay. Install package. Okay. Kalau tak ada multi-com ni, multi-com ni, boleh install. Kalau kamu nak tahu apa install package multi-com ke apa ke, boleh search kat sini. Contohnya kita nak tahu kan, what is multi-com ni, install package, what inside this package. Apa saya type? For example, multi-com. Kita boleh tengoklah, this is the example MTDS source code for this package. Then run it. Please, okay, kalau kita belum tu dia akan ambil sedikit masa to download the package. Betul tak? Then we run for the library. When we want to use it, we have to put library multi-com. Okay. Is it okay? Okay tak? Kita nak run yang ni je, yang atas ni je, slide 24. Lepas tu kita analyze apa yang dia bagi tahu. Then we attach cholesterol punya table. A table TRT. And table TRT. Inilah tadi, which is 1 times 22, okay, drop 10, 10, 10. Sekejap ya. Sepatutnya group of sample size. Yang tadi yang ni is group of sample size, which is 10, 10, 10, 10. And head of cholesterol punya table tu kita nak tahu what does the cholesterol table ni contain of dia punya head, column yang atas sekali tu kan. Macam hari tu kita belajar the function head ni, kita nak tengok yang atas apa yang dibagi.
Doktor, data kolesterol memang dah ada dalam library tu ke?
Dekat dalam R.
Okey.
Betul tak? Ada tak kat kamu? Ke tak habis lagi yang download package tadi tu?
Ada.
Okay kan? So we are now in line 8. Nanti kita tengok satu-satu what does it mean. Kita run dulu. Okay, this is the head of cholesterol tu kan. Okay, so kita tengok kat situ dia ada 1 time, 2 time. This is the response here. And for the drug D, what is the response? And the drug E, what is the response? This is aggregate response. The line 9. And also for the aggregate, this is the standard deviation. And saya run tadi, saya highlightkan tu. Okay, then this is we fit using analysis of variance response TRT. And we want to know the summary of this fit. Kalau kat sini kita define dia analysis of variance ni as a fit. Then what we want to know the summary of that particular fit. And this is the summary. Nampak tak kat sini kita ada F value. Then this is our P value, which is value ni lagi besar daripada F punya value. And this is the library Gplot because okay. So sekarang kita tak ada Gplot punya package. Before we call for, saya tak ada Gplot punya package. Saya boleh install Ctrl Z. Saya letak kat atas ni. Saya letak Gplot. Kalau kamu ada problem dekat macam saya Gplot ni, tambah dekat atas tu before we call for library Gplot, we install package first. Right? Lepas tu baru boleh panggil Gplot. Kalau macam tadi, kalau kamu dapat error, if you got some error which is error there is no package, kamu kena letak install the package first, then baru library Gplot. Then we plot mean dia. Nampak tak kat sini? This is the mean plot dia. Okay. Sekejap. Dash cholesterol. Okay. Sekejap ya. Kalau dah selesai run sampai situ, bagi tahu jom kita discuss apa maksudnya. Tadi kita buat sampai mana tadi? Sampai yang ni. Line 19 ni. Jadi tunggu dulu. Okay, sometime untuk semua selesaikan. Dan kalau dah semua selesaikan baru kita discuss ya.
Sampai detach kolesterol tu.
Sampai situ je.
Okey.
Dah. Abika.
Saya dah.
Dah. Anis tengah Adiba kalau dah bagi tahu ya.
Saya dah, doktor.
Okey.
Saya dah juga.
Okey. Sekarang kamu nampak saya punya apa?
Hitam je doktor.
Blank.
Blank. Sekejap ya. Sekejap. Sebab saya tengah buka satu benda ni. Okay, we go for our R. Ni nampak R kan? Okay, kita pergi satu persatu yang dekat bawah tu dia tunjuk apa kan? Daripada yang tadi yang atas, tadi kita buat apa? Yang ni maksudnya this is table TRT, this is our sample size. This is our sample size. Okay. Then we know that our sample size balance, right? 10, 10, 10, 10. Then this is by using the group means number 2. Number 2 ialah okay, from the means it appear that drug E produce the greatest cholesterol. Okay, nampak tak kat sini? The greatest cholesterol. Yang ni which is drug E produce the greatest cholesterol reduction whereas one time produce the least. Okay, maksudnya yang ni. One time ni produce the least 3 point. Saya tengok hit cholesterol. Time. Okay, this is the mean dia. Dia dapat mean. Before we go for this, ini ialah satu persatu yang dia maksudkan tadi. Yang kan 10 kan. So sekarang kita nampak dia 10 punya mean. And this is the ini ialah 10 punya respon. Then this is the mean. Dan daripada sini kita nampak dekat situ group mean. This is by using the group mean. Which is kat sini ialah ini ialah head kepada kolesterol tu. Sekejap ya kat sini. Yang ni. Ni. Okay. Nampak tak kat sini? Yang ni, aggregate respon ni ialah yang atas ni ialah dia punya value respon. Satu persatu tu kan dia ambil yang pertama, yang 6 pertama ni dia ambil yang kolesterol untuk one time je. So this is the 6 yang pertama. Okay, nampak kan? Okay, and yang bawah kolesterol ni bila kita call for kolesterol, it give all the yang 10 sample size ni on each variable tu. Okay, so one time untuk yang pertama punya respon until the drug E. And this is the group mean. By using the drug E, kita nampak drug E tu produce the greatest cholesterol reduction, whereas one time produce the least. Maksudnya sekarang one time ni yang paling kecil and the greatest punya tu from the drug E. Okay. By using mean lah kat sini function dia. Okay, boleh. Apa yang kita buat tadi. Can we continue? And by using
sorry. Maksud aggregate tu dia dah groupkan terus lah. Maksudnya cari mean untuk one time, mean untuk
by using dia dah group kan. Kita kadang-kadang kita nak tengok satu persatu, kalau data dia 10 kita boleh nampak kat atas ni kan. Tapi bila kita nak the summary tu kan, kita nak tahu by using mean apa yang dia bagi.
Summary by group lah.
Okay. Then lepas tu group standard deviation ni kita guna function dia ialah standard deviation pula. Standard deviation dia bagi kita apa tu? Standard deviation were relatively reduction, whereas standard deviation were relatively constant across the 5 group, which is ranging dia between 2.88 to 3.48. Maksudnya kita nampak dia constant, macam dia dah lebih-lebih kurang sama je. Then this is the average, dia punya value tu between the 2.88 and yang paling tinggi ialah 3.48. Betul tak? 3.48 yang paling tinggi. Kita nampak dia quite constant lah. Jadi kalau macam if we have the data, then first we have to describe our finding kan. So just now kita tak nampak dekat mean tu, we can find the greatest one and the lowest one kan. And from this standard deviation we can see it quite constant and the value for this is between one value to other value, right? That's how we summarize our finding. Then kita nak guna ANOVA pula. This is analysis of variance daripada respon tu. How can we conclude? Okay, the ANOVA F-test for treatment TIT is significant because the p-value is less than 0.001. Nampak tak p-value kat sini? It is okay. Kalau macam ni, which is dia kali 10 kuasa negatif 3 kan. Kalau macam ni dia bergerak, kalau kita dulu-dulu kan kita belajar the decimal place ni, dia bergerak ke depan sebanyak 13 kali kan kat situ kan. So it is less than, p-value dia ni less than 0.001. So it is significant. Okay. So apa yang kita boleh concludekan dekat sini? Ini berdasarkan value yang belakang ni. Okay then. For the treatment, okay. Providing that the 5 treatment unequally effective. Maksudnya dia tidak equally effective. Okay. Dia tak ada equal effective. Okay. Maksudnya the variance dia punya perbezaan tu dia memang berbeza lah. It's not equally effective. Then number 5 from the our plot means ni. Okay, apa yang kita boleh concludekan kat sini? Yang mean yang kat sebelah ni dapat tak?
Nampak?
Kamu dapat kan?
Dapat?
Okay, so sekarang kan bila kita tengok this is the response just now. Okay, value yang kat sini ni dia bermaksud apa? Okay, so kita tahu bahawa from our data yang paling tinggi ni kan dah dekat around 20, which is this is the drug kita punya value and this is the sample size just now, right? And 10, 10, 10. Then this is the response by using function mean. Kan nampak tak mean dia kat sini nampak tak? Kan? And this is the mean for the 2 times which is 9.22 kat sini around this. Kan yang bulat ni is a mean. Okay. Mean plot with 95%. Oh, apa? CR just now? Significant level. Significant is S. Okay. Tengok CR ni. Okay, so the plot mean can be used to produce a graph. Group mean dia okay, it is a what? Confidence interval. Okay, in their confidence interval. Okay, then a plot of the treatment means with 95% confidence limit is provided in this table, in this figure. Okay, then you can see clearly this treatment difference. Maksudnya kita nampak the difference between this statement. Okay, we graph it by using the table. Okay, just now dia punya code tu kan. This is okay. Okay, this is the finding from the yang slide tadi tu, slide 24. Okay. Then inilah yang slide tadi tu, inilah yang kita dapat tadi. Kita dapat dia lebih rendah daripada p value kita 0.02. Jadi kita tahu it's dia ialah different from each other, which is not equally similar. And this is the treatment group. And this is the finding yang kita nampak tadi, yang kita dah discuss tadi tu lah. Sama lah ni. Okay, see the treatment different. Perbezaan dari segi treatment. Analysis of variance. Kita kena ingat this is the topic of analysis of variance. Kita nak tengok the variasi. Maksudnya sekarang our case now, the variasi from the different which is kita ambil drug tu dengan miligram yang berbeza, different time, which is sekali ambil, 2 kali ambil, 3 kali ambil, and different type of drug B and drug E. This is the variance, the difference yang kita nak tengok, the analysis of variance. Okay. Then the following is the multiple comparison. We want to do a multiple comparison pula kat sini. Okay, the ANOVA F test for treatment tell you that the 5 drug regimen unequally effective. Dia tak sama kan? Dia efektif dia berlainan kan? But it doesn't tell you which treatment differ from one another. Yang mana satu differ from one another. You can use multiple comparison procedure to answer this question. For example, 2K HSD function provide a test of all pairwise different group mean listing in 9.2 macam ni. Okay, kita nak tahu the list kan? One to another macam mana. Okay, then this comparison we will do it in R. Then note that the 2K HSD function has comparability issue with package HH also used in this chapter loaded by okay, we'll fill. In this case, we use detach package hash to remove it from the search bus and then call HSD. Okay, yang ni is in terms of syntax lah. Okay. Then 30 is okay. Yang ni nanti kita tengok. Kita run dulu daripada R. Cuba run yang seterusnya yang tu PHSD fit ni. Multiple comparison on this level. Formula respond and this is the then this is parameter tau. PAR is parameter. Okay, we run it. And after then we use parameter C5842. Nanti kita terangkan dia. Then we plot. Sekarang kita nak plot pula token apa. Then we feed it. This is the track just now. Okay. Apa yang dia plotkan dekat sini ialah tak kat sini. Apa yang diplotkan? Confidence level. Okay. So nampak tak how does this plot mean? Okay, this is the difference 3.443 2 to 1 time. Okay, kita nak tahu 2 to 1 time. Okay, 2 to 1 time kat sini kan data awal ni. Then the different, the lowest part is negative 0.6. Nampak tak? 2 to 1 time ni yang paling kecil dia kat sini. Negative value. Negative. And the upper part dia 7.5544 kat sini. Nampak tak? This is the 7 dia dekat sini. And this is what is its mean. It is the difference dia. 3.443. Nampak tak dia dekat situ? 3. Then kalau yang kedua pun dia punya difference 6.59. Nampak tak dia diplotkan dekat 6. Okay, yang tengah-tengah ni is the difference. The data difference, and this is the first one is the lower one and P is the then okay, ni is kita nak buat multiple comparison. Then okay, bila kita guna this is the family wise confidence level. Okay, this is the P value dia. Apa yang dia maksudkan? Okay, so sekarang dekat sini kita nampak tak? Mean for 1 and 2 time unsignificant. Dia tak significant. 1 to 2 time. Okay, kat sini kan 1 to 2 time. Kat sini yang pertama ni tidak significant. Kenapa? Dia punya P is equal to 0.0138. Whereas the difference between 1 and 4 time is significant. Contohnya kita ambil dua data yang awal ni lah. Okay, this is the significance punya different, which is dia punya value between 1 time to 4 time it is less than 0.001. Okay, so sekarang yang ni ialah significance lah dia punya difference ni. Okay, and you can go for the next punya comparison. Okay, kalau drag D to 1 time is it's also significant because it's less than 0.01, and for this 4 time to 2 time is not significant because it is greater than P value. Same as this one, drag D to 4 time is not significant. Okay. Okay, for this, at first pass statement rotate the axis level. Okay. Ada apa persoalan tak?
Tak ada, doktor.
Okay, so kita teruskan. Okay, so tadi kan kita guna. Okay, so sekarang cuba kita buat ni. Apa perbezaan yang atas ni dengan yang bawah ni? Sebab dia sama je. Okay, cuma kita nak fit ni kita guna box plot kat sini. Plot CLD. This is by using 2 key jadi fit. Okay, then we try to, okay, kita run untuk Malcolm ni. Multi comparison. Okay, library. Boleh ke? Kalau tak boleh yang Malcolm ni letak library.package dulu. Then PAR parameter kita 5462 dan we name is okay. GLHT ni ialah kalau tak tahu boleh search dekat sini juga. Help kat sini tahu. Tapi kat sini GLHT ni ialah Malcolm package provide a much more comprehensive set of method for multiple mean comparison that you can use for both linear models such as those described kat sini lah. Generalized linear model, Okay, then the following code. Okay, this is the code dia lah untuk GLHT. Instead of we just feed it by using toolkit, we use GLHT. Okay, so now we run it. Then we plot. Yang ni plot yang tadi kan? Okay, so sekarang kita plot pula guna CLD. Nampak tak? It is box plot kat sini kan? Okay, apa perbezaannya? Okay, just now dia sama je. One time dia bagi tahu kat situ tadi, kalau one time kat sini, nampak tak? One, two, dia punya apa difference dia dekat yang 6 tadi, the lowest and upper kan? Okay, but here, in the box plot, the assemblator don't have significant difference. You can see that 1 and 2 time are significantly different. Okay, nampak tak kat sini? Macam ni. Dekat box plot ni, kan saya punya ni dia macam okay, bila kita macam ni kita nampak. Kalau macam ni kan dia macam hilang kan yang dekat atas ni. Sekejap saya besarkan. Okay, apa tak? Yang second time ni A dengan B, yang first time ni A. Jadinya bila kita guna box plot ni kita nampak yang dekat mana dia letak dah value A, B, B, C, C and D. Okay then. Dekat sini, group represent in box plot that have the same letter don't have significant difference. Okay, maksudnya yang ada same letter, maksudnya one time to two time dia ada dua value A yang berkongsi, so it is not significant. Okay, like this punya value lah tadi, it's not one time to two time to one time is not significant to each other. Okay, because it sharing the A just now. Okay, both have the letter A. Okay, then the two time and four time insignificant. Okay, two time, this is the two time and this is the four time also is not significant also because it they have the both letter B. Ini yang menunjukkan dia tak significant. Dua-dua ni ada letter B. Okay, but one time and four time, one time and four time, it is significant. Because they don't share any letter. Nampak tak kat sini? This is how we can see the significance. Kalau macam kita guna plot yang tadi, kita tak nampak the significance tu. Because it doesn't show the value macam ni lah. Okay, yang ni dia gambarkan dalam A, B, B, C. Kita tengok whether it has the similar letter, so it is not significant. Contohnya macam ni, 4 times and drag D, it is not significant because it has the letter C. Then dekat situ dia beritahu bahawa easier to read this kind of plot rather than yang plot yang tadi lah. Okay, from this result can see that the taking cholesterol lower drug in the 5 mg 4 times a day was better than 20 mg dose per day. Maksudnya kita kena ambil sikit tetapi berkali-kali is better than ambil banyak, which is 20 mg dose per 1 day. Okay. The competitor drug D wasn't superior to this 4 time per regimen. Drug D, 4 time per regimen. Sebab kenapa? Sebab dia tak significant. Okay. But competitor drug E was superior to both drug D. Okay, maksudnya kita nampak daripada result yang ni, kita nampak this is the most superior because it is to both drug D and all the dosage strategy for our focus drug. Maksudnya kat sini. Drug D most superior and it is significant to the 4 time because then it is also significant to the 2 times and it is also significant to the 1 time. Okay. multiple comparison methodology is a complex and rapidly changing area to study. Okay, inilah still kita boleh more explore to this area because it's still changing area. It has a lot of improvement to do. Okay. Any question for this? This is how we find a significant daripada maksudnya faktor yang kita ambil one time to two time, okay kan? This is what we call a multiple comparison. Okay ke ni? This is the result just now kan? Yang kita buat tadi. And this is by using kenapa one time to two time, p value dia tadi 0.13 which is not significant, unsignificantly different. Kenapa? Sebab dia value dia besar ni. It is not that less than 0.01. Okay, sini kita ambil p value significant kita ialah 0.01. Okay. Then this is the graph that we get just now. Then we do another comparison by using yang GLHT just now. We obtain this box plot graph. Then from this box plot graph, we found the significant to those yang tak ada similar letter, which is we know that 4 times is more significant to 1. Okay, 1 and 2 times is not significant because they have 2 letter. It represent significant or not. Kita tengok letter ada sama tu is not significant. And this is the explanation just now. We are go to the slide 36 yang ni saya, sebab ini kita dah buat dah tadi. Saya dah explain dekat dalam R tadi tu. And we go for the assessing test assumption. Macam mana kita nak buat assessing test assumption. Then as we saw in the previous chapter, our confidence in the result depend on the degree to which our data satisfies the assumption underlying the statistical test. Okay, in this one Way Anova, the dependent variable is assumed to be normally distributed. Dependent variable yang bergantung tu, yang Y tu, and have equal variance in each group. Kita one Way Anova sekarang ni variance dia sama dalam setiap kumpulan. Then you can use QQ plot to assess the normality assumption. If you want to find the normality assumption, we can use the QQ plot. The data fall within the 95% confident envelope, suggesting that the normality assumption has been met fairly well. Kalau misalnya contohnya dia punya confidence tu dia dalam 95% confidence tu, which is we can assume that it is fairly well punya normality. Okay, then we go for the lab. Apa yang dimaksudkan kat situ? Kita akan dapat graph ni dan kita akan dapat result ni. Okay, then we go for the R. Okay, sekejap kita kat R, sekejap kita dekat okay, dekat slide. Sekarang ni we are assessing assumption. Okay, now we go for the just now the explanation in the slide 36 and so on. And this is we call the library car. What is the function car? You can find it from here. Try to search, and it's loading required package car data. We have to wait. Then finish and QQ plot. Tak kat sini. Dapat ya? Sekarang ni nampak tak QQ plot ni dekat sini dia pakai LM, which is linear model. Sebab data kita pun linear kan, this is linear model. Feed the graph provided as this, then data fall within 95% confident envelope, suggesting that completely fair. Okay. Okay, after that, checking the equality of variant homogeneity. You want to check by using the Bartlett test. Okay, here. Okay, then okay, nampak tak kat sini? By using the Bartlett test homogeneity of variance, we found that the k squared is 0.57, the difference kat sini 4, and the p-value ni nampak tak besar ni, 0.96. Okay, that the Bartlett test indicate the variance in these 5 group. Ingat lagi kita punya tadi ada 5 group. Apa tu? Yang tadi tu lah. Which is the 5 group yang kita groupkan kita punya sampel tadi. Ingat ya, 1, 2, 3, 4, 5. Yang asal-asal ni. We still in this data. Then here, 5 group don't differ significantly because our P just yang ni 0.9653. Other possible tests include the Flingner-Killen test, provide the Flingner test function. Okay, so sekarang kita boleh guna juga test ni provide by the HOV. Okay. Here, then selain daripada test yang kita ada dekat ni, Bartlett test ni, kita boleh guna juga Flingner-Killen test provide by the, okay, test tu ialah ni, kalau kita tengok kat sini dekat nota ni, here, we are here, kita guna Bartlett, so kita dapat yang ni kan tadi. So, other than this, we can use other tests also, and this is by using the Bernford-Rennie methodologies can be sensitive to the presence of the outlier. You can test for outlier test function using this car package. So here we found that our p-value is berapa tu? Adjusted. Okay, so it is NA occur when the p-value is greater than 1. Okay, so kita tengok dekat R ni apa jadi kat sini, kita tengok. So this is the car just now. See the library car also. This is the outlier test. Fit nampak ni. Bernford-Rennie. Kita tengok by using the Bernford-Rennie kat sini. Okay, from here. Okay, analysis of variance methods can be sensitive to the presence of the outlier. Then from the data output, you can see that there is no indication for outlier in the cholesterol and data. There is no indication for the outlier. Maksudnya dia tak ada outlier occur when P is greater than 1. Taking the QQ plot, Bartlett test and the outlier test together, the data appear fit ANOVA model quite well. This in turn add to your confidence in the result. Okay, so kita tahu bahawa our data is quite well from here. Then, what we want to do? One way ANOVA, apa tu? Kita nak seterusnya ialah kita nak tambah covariant dekat situ. Okay, one-way analysis of covariant extend to the one-way ANOVA to include one more quantitative covariant. Kita tambah. Daripada yang tadi yang ada tadi tu kan. Kita tambah satu covariant. Okay, then kita tambah pregnant mice were divided into 4 treatment group. Each group receive different dose. Maksudnya 0, 5. Kita ada different dose of drug. 0, 5, 50, 500. This is our covariant that we tambah. The mean post-birth weight for each litter was the dependent variable and the gestation time was included as a covariate. So let me see in our R. Then this is the gest time and dose. And this is the result that the R from the analysis of covariant. Okay. Mesti kita tengok sekejap Kita pergi dekat R sekarang. So, kat situ, sini analysis of covariant. Kita tambah data litter kat situ. Then, attach litter. Then, table kat situ ada dose kan. Then, this is the dose. Kita nak tengok dalam table tu dose ada berapa. Okay. Different dose of drug. Okay, contohnya 0, 20 dos, 5, 20, 19 macam tu. That's the different. Then, from the table kat situ dose tu, you can see that there are unequal number of liter at each dose level with 20 liter at 0 dosage, no drug, and 70 liter at the dosage 500 kat sini. Okay. Then we find the aggregate. We want to know by using mean. Macam mana dia punya mean tu. Okay, so we run this. Okay, this is by aggregate just now. Mean for each group. Kalau no dosage tu, mean dia 32. 5, 29. Okay, we found that the no drug group has the highest mean liter weight, which is yang ni yang paling tinggi, no drug. Okay, the ANCOVA test. Now we fit by using the analysis of variance. Okay, so we run it. Then we summary of this fit. Okay, nampak tak kat sini? Okay, so sekarang daripada ANCOVA F test indicate that A just the time was related to birth weight, and B, okay, ni just the time apa? Related to the birth weight, and B ialah drug dosage. B ialah drug dosage yang bawah ni. Okay, was related to birth weight after controlling for gestation time. The mean birth weight isn't the same for each of the drug dosage after controlling for gestation time. Okay, so sekarang kita nampak tak mean dia kat sini isn't the same for the for each of the drug dosage kat situ. So sekarang because you are using the covariate, you may want to obtain adjusted group mean. Sekarang kita nak adjust group mean tu. Okay. The group mean obtained after partitioning out the effect of covariate, you can use the effect. Okay, now we are using the function effect sekarang ni. Effect ni ialah we want to kita nak modify a bit dia punya mean ni kat sini. Okay. So here this is the install this package first.
I have a question. Contoh kan, kalau macam kita ada data sendiri, lepas tu kita nak masukkan ke dalam R, boleh ke?
Boleh.
Oh.
Yang the first class hari tu kan I teach you about read. Kita read kan read.
Oh, okay.
If we have data like actually for example, if you want to take data from the website, for example, di dalam TXT kan. Okay, we can convert the data TXT into the data frame Excel, macam Excel kan. Boleh convert. Tengok balik nota tu.
Okay. Alright. Thank you, Doktor.
from the book that I give you today is also tell about the how to manage our data. Okay, then this is our install package. So kita dah install. Then this is library effect. Kita nak guna effect ni. Then kita dose and fit. Okay, so sekarang kita tak nampak tak kat sini. Bila awal-awal tadi kan, before we are using effect, dia punya 32.3, 29 dia punya min kan. Okay, now after we are using the effect punya ni, okay, it a bit changes here by using the effect punya package. Okay, dia berubah sikit lah. Okay then. Now. Okay, so adjusted mean are similar to the adjusted mean produced by the aggregate function. Okay. Sama dengan aggregate function yang dia bagi dekat adjusted mean tu kat sini. Aggregate function kat sini. Sebelum tu lebih kurang sama. Okay. Tapi dia ubah sikit saja tu. Kalau kamu boleh tengok balik, kamu punya value yang atas ni boleh compare. It's a bit different. Then sekarang kita nak tengok those effect those fit. Okay, so kita ada kat situ 32.4 dalam tu 28 point ni. Okay. Okay, the effect package provide a powerful method of obtaining adjusted mean for complex research design and presenting them visually. So see the package, boleh tengok lebih lanjut ya, effect punya package ni on crime ke, dekat R yang ni ke, for more detail. Okay. So as with the one Way Anova example in the last section, the F test for those indicate that the treatment don't have the same mean birth weight, but it doesn't tell you which mean differ from one another. Okay, yang tadi tu kan yang kita dapat satu result yang NA tu kan, kita tak ada result for that. Mana ya tadi? Ni okay, maksudnya sekarang kat situ, those indicate that the treatment don't have the same mean birth weight, but it doesn't tell you which mean differ from one another. Kita tak tahu. Again, you can see the multiple comparison procedure provided by Malcolm. Kamu boleh buat yang macam Malcolm tadi. Yang Malcolm yang kita buat plots, box plot tu, to see the difference between one another. To compute all pairwise mean comparison. Additionally, the Malcolm package can be used to test specific user-defined hypothesis about the mean. Okay, we want to see the multiple comparison tu, kita boleh buat box plot tu balik. Okay, suppose you are interested in whether the no drug condition differ from the 3 drug condition, the code in the file. Okay, so we can use ni Malcolm. Nampak yang ni kita buat sekarang. Macam mana we want to see the multiple comparison. Okay. Okay, this is we are using no drug versus drug kat situ. Macam mana dia punya comparison. Okay, then apa yang dimaksudkan dekat sini? Okay, sekarang dia dapat p-value kita 0.01, then okay, this is the linear hypothesis between no drug versus drug. Okay, what does it mean? Okay, so apa yang dia buat tadi yang kontras C3 negatif 1 tu specifies a comparison the first group with the average of the other three. Okay, this is the average of other three. The hypothesis is test with a statistic. T-statistic kita dapat 2.5.581 in this case, which is significant. Okay, it is significant at the p-value less than 0.05 level. Therefore, you can conclude that the no drug group has higher burst rate than a drug condition. Okay. No drug group has the higher burst rate than the drug condition. Sebab dia ada significant difference kat situ. Kat sini dia like greater. Jadi kita tahu bahawa dia ada kita boleh conclude kan kat situ yang tiada drug group has higher birth rate than drug condition. Okay. Then we go for the next one. Yang ni yang kita buat tadi. Gestation time, dose yang kita buat tadi. That I mentioned just now. Dekat situ kita buat gestation time related to birth weight. Lepas tu drug dosage. Yang kedua kita dapat drug dosage related to birth weight. Okay. Yang ni kita punya covariance yang kita tambah tu lah. Gestation time and drug dosage. And this is the 43 yang ni pun kita dah buat. We are doing the effect tu just now. The mean value tu kita ubah sikit by using the effect function. Then we run for the code. After that, we do the multiple comparison. We found that kat sini yang ni lah. Maksudnya, no drug group has higher burst rate than drug condition. Okay, this is what we do just now. Okay, other contrast can be added to R band function. See, kita boleh tengok help GLHT for detail. Boleh tengok kat sini, boleh type dekat sini ya, dekat R ni. Okay, boleh find dekat situ. Help. Okay. So sekarang we are doing the testing for homogeneity of regression slope. Okay, so sekarang kita dekat sini, assessing test assumption. Okay, yang kita nak buat homogeneity of regression slope. Okay, Ankova design analysis of covariate. Sebab tadi kita dah tambah covariate, dua covariate tu. Yang gestation time and just now yang lagi satu apa tadi? Drug dosage tu. Okay. So far so good.
Doktor, macam mana nak tahu no drug to higher birth?
Kita tengok result tadi kan?
Daripada p-value tu ke?
Bila kita tengok p-value tu dia rendah, maksudnya dia rendah daripada 0.05. Sebenarnya p-value we set it as 0 sebab dia 95% punya significant level kan. Jadinya dia yang 95% yang baki kat 95 ialah 5% kan? Belakang tu. So kita nak tahu dia significant or not, dia mesti less than 5% yang beza yang belakang tu. So it is significant. So kita sekarang kan kita tengok bila kita buat one test kan, bila kita compare dua ni kan, no drug versus drug, bila kita tengok significant ni dia rendah, maksudnya dia less than 0.05, kita tahu bahawa dekat situ dia ada different. Dia punya different dia ada significant level of different macam tu.
Oh.
Dia macam mana? Kadang-kadang kita tak faham sangat Afika. Saya kan bila mula-mula I know your concern because when I learn statistic mula kita macam tak faham dekat mana macam how can we measure kan? How can we conclude? Betul tak? Kan? Tapi bila kita buat eksperimen, bila saya buat eksperimen, when we have one benchmark eksperimen, benchmark ni ialah the previous punya work. Kita guna dia punya teknik, ni saya dah bawa kepada saya punya masalah lah, dia bukan yang orang ni punya dos yang pada tadi ni. Saya buat saya punya eksperimen, when I'm doing the experiment, saya guna image tau. Saya produce satu macam nak cari local value tau. Maksudnya kita nak tahu the impact of our punya adakah kita punya method ni bagi significant result of study ke tidak? Macam tu, macam kita nak measure. Ini case kita sendiri kan. Kalau ini orang ni dia dah ada data, so kita boleh tengok P value dia, betul tak? Kan? Kalau macam saya kan, what I'm doing is I want to know the impact of my proposed study. Okay, saya ambil benchmark which is orang tu dah buat method tu. So kita ambil result dia menggunakan data set kita. So kita dah ada result dia. Orang tu punya result on our case study lah, maksudnya. Okay, so kita nak tahu the impact of our study kan yang saya propose tu. Saya dah ada result of saya dah ada list of result of my propose untuk bermacam-macam image tau, macam ni. Macam ni lah, saya kadang-kadang tak nampak, kita kena lukis. Okay, yang ni saya punya macam ni kan. This is my proposed result. Okay, ini contohnya ini daripada previous study. Previous study punya result. Okay, previous study, this is my proposed result. Ni yang saya buat. Okay, for contohnya for 200 image, saya dah letak saya punya method tu, saya dapat result ni, yang ni kan. Okay, so sekarang dekat sini, orang ni punya result memang dah ada. Dia macam this is his method lah, maksudnya dia punya cara. Okay, kita dapat result yang ni. Okay, we want to know the significance of our study. Kita nak tahu the significance of our study. Saya cari P value untuk saya punya ni, saya compare dengan ni, which is my PR versus dengan PS daripada result yang dia ada lah. Maksudnya saya gunalah semua data set saya. Maksudnya saya punya data saya guna 200 image just now kan. Yang ni pun saya guna 200 image tapi guna method orang ni. So saya dapat this kind of value. Value ni sebenarnya dalam image yang sama. Yang pertama gunakan image yang sama. Yang kedua guna image yang sama. Yang ketiga guna image yang sama tapi method yang berbeza. Ni method orang tu. Yang ni method saya. Okay. So then bila kita buat PR versus dengan previous punya study punya result. Okay, saya cari P value. P value saya kat situ saya dapat, contohnya saya dapat 0.015. Even though dekat sini sebab kita nak check satu-satu, kita tak akan terbuat tau kalau kita ada data yang banyak. We have to know the significant level tu lah, significant, how significant is our study. Contohnya kat sini kan, kejap orang tu tinggi, kejap kita yang tinggi, kejap orang tu it will variety, right? Maksudnya kadang-kadang dekat satu image ni dia tinggi, saya rendah. Ada dekat satu image ni dia rendah, saya tinggi. Macam tu, kita tak akan tertengok satu-satu. Itu sebabnya kita kena buat significant study. How significant is our result based on previous study. So this is where we find the P value. Contohnya the P value tu saya dapat, dia punya P value tu ialah 0.015. Ini kita tak payah nak guna, kalau guna R kita boleh cari, kalau guna MATLAB ke Python ke semua dia dah boleh cari dah P value tu. So if we get the P value ni 0.05, so kita boleh kata dia less than 0.5, which is we are in the 95% in the significant level. So we can conclude that our study is significant enough because it has the different from the previous study. Macam tu. Boleh?
Oh, faham. Itu kegunaan dia lah.
Itu kegunaan dia. Kalau macam yang orang ni, dia punya tu ialah dia nak tahu significant between kalau no drug dengan drug, so dia dapat P value tu yang ni. So kita tahu bahawa ada impact dengan tak letak drug dengan ada drug. Kalau contohnya dia dapat, contohnya dekat sini dia dapat 0.78 macam tu kan, dia punya significant level, dia bukan less than 0.05. Jadi kita rasa study ni sebenarnya macam tak ada memberi impact pun.
Faham.
Kan? Macam tu. Boleh?
Boleh.
Sebab Dulu saya pun when I'm studying statistik, sebab kita tak tengok lagi our eksperimen. Jadi kita tak lalui lagi kita punya eksperimen. Jadi kita tak tahu nak guna dekat mana. Kita nak memahamkan orang ni punya data pun satu hal juga, betul tak? Kita tak nampak. So itu yang ada pada study yang saya buat, dan saya cari p-value kat situlah. I want to know the impact of my previous of my proposed technique. Kalau dia ada significant level dia punya result tu less than 0.05, bahawa saya boleh conclude that there is some changes, that the good changes that I had made from the previous punya study. Macam tu. Okay. Okay, can we continue? Kita continue.
Yes.
So sekarang kat sini ialah assessing the test assumption. Kita guna Anova tadi design ni. Anova, Anova is not a big maksudnya macam different, which is dia tambah covariate je kat depan tu kan. Bila dia tambah covariate daripada faktor yang kita ada, so we call it as Ankova. Okay. This is normality homogeneity of in the addition standard Ankova design assume homogeneity of regression slope. In this case, it assumes that regression slope for predicting birth weight from gestation time is the same in each of 4 treatment group. In this case, it assumes that the regression slope tu mesti birth weight tu dia nak kata dia the same in each 4 treatment, maksudnya sama. Okay, a test for homogeneity of regression slope can be obtained by including the gestation dose, time dose interaction in terms of Ankova model. Okay, so kita tengok apa yang dia buat. Nanti kita akan dapatlah semua ni. Okay, so kita cuba buat dekat sini. Okay, now we are doing the interaction between gestation time and dose. Ada kat sini. Sekejap. Okay, we run. Okay, we name it as fit tu, sebab sebelum ni kita dah ada namakan fit kan. This is analysis of variance. Why kita punya dependent variable tadi tu ialah weak. Kita nak tahu dia dependent. Dia bergantung kepada gestation time and dose. Lupa tadi kita nak tengok dekat atas tu kan nampak ni. Weight, gestation time dengan dose. Dekat mana yang faktor A and faktor B. Yang ni ialah relation between faktor A and faktor B. The dependent is out, the weight. Then we see the summary. Okay, fit and summary the fit. Okay, tengok tak kat situ. This is the gestation time and this is the dose. Gestation time tu kita nampak dia ada impact kat situ. It is less than 0.05 and also for the dose, but these two dia tak ada significant impact kan, maksudnya kat situ. Nampak tak? In this case,
Nampak p-value dia tinggi.
p-value dia tinggi. Kita tengok kat p-value dia tu. Kan? In this case, is assume that the regression slope for the predicting birth from gestation time is the same in each other 4 treatment group. Maksudnya dia tak ada different pun kat situ. Sama untuk ke semua group tu. A test for homogeneity of regression slope can be obtained by indicating the gestation times dose interaction in terms of Ankova model. A significant interaction will imply that the relationship between gestation and birth weight depend on their level of dose variable. Okay, then we know that the interaction is non-significant supporting the assumption of equality of slope. Maksudnya kat sini. Ini dia tak ada different, maksudnya sama je untuk keempat-empat group tu. Okay. Okay, macam mana kita nak visualizing our result? Okay, this is the visualization. Okay. This is using H. Okay, this is the package H. Boleh type kat sini, nanti boleh baca what is the package H ni. Okay. Sebab kita kan kita jadi more familiar tu ada punya apa bahasa punya syntax kan. Kadang kita tak boleh nak hafal, so that itulah gunanya nak search apa lah syntax dia untuk HH ni. How can we do a visualization for this? Okay, then we call for the library list page. Then wait until it load. Then after finish loading, we run for the Ankova way yang kita nak visualize Ankova punya ni. Right. Okay, this is the analysis of variance table. Nampak tak? Gestation time and dose ni ada significant punya difference. Okay, so yang tadi tu kita dah tak ambil lah sebab yang bawah sekali tu dia macam dia tak ada significant difference kan yang bawah tadi tu. The interaction between these two tu kan tak ada, so we focus on these two only. Then this is the graph. Saya besarkan ya. Okay, from this graph, okay kat sini, this is the legend lah yang biru tu. Ini kenapa legend ni? Ialah ini kita letak dia dalam the same graph on the 0 punya no drug and 5 sampailah 500 tu. Okay. Gestation time. Okay, this is the weight. Weight ni ialah dependent variable. So kita nampak tak kat situ gestation time plus dose. Kita nak tahu faktor kepada gestation time and dose. And this is the dose. Titik-titik tu. Okay. And what does it mean? Okay, produce a plot in following. Okay. Here you can see that the regression line ni for predicting birth weight from gestation time are parallel in each group. Nampak tak? Semua macam parallel kan? Dia memang parallel lah. Selari. Sama je. But you have different intercept. Intercept tu apa yang dekat Y kat sini kan different intercept. Yang ni Y dia 30. Ini ialah 26 dalam around that. Okay, this is around between atas sikit daripada sebelah ni. 5 and for 500 is more similar to the 5. Okay. As gestation time increase, apabila kita naikkan gestation time, okay, birth weight increase. Gestation time increase, then our birth weight is increased. This is the gestation time. Okay, bila kita naikkan, then birth weight dia increase. Birth weight. Macam mana? Sekejap saya pun nak fahamkan dia punya graph ni. Sini. Okay, this is the gestation time and the birth weight. Yeah. Okay. Additionally, you can see that the 0 dose, here is 0 dose, group has the largest intercept. Intercept dia lagi tinggi. And the 5 dose group has the lowest intercept. 5 dose ni lowest intercept. Okay, the lines are parallel because you have specified them to be. Okay, if you would use the statement Ankova gestation time times dose, instead you generate a plot that allow both slope intercept to vary by group. Okay, yang ni kita yang setkan dia sebab dia ialah tambah kat situ sebab tu dia parallel. Kalau kita tukar kita punya kod ni, mana tadi? Macam mana nak? Okay. Kalau kita tukar kod kita ni kepada darab yang ni, kita nak tahu relation dia, dia akan jadi berbeza lah, dia tak akan jadi parallel. Okay. Then you generate a plot that allow both of slope and intercept to vary different group. This approach is useful for visualizing the case where the homogeneity of regression slope doesn't hold. Okay, so this is the way we combine all those with the combine this model by using the Gestation factor and those factor in one graph. Okay, so we can see that the highest one is from the 0 dose and the lowest one is from the 5 dose. Okay, this is how we visualize. But we can see the different tu memang ada lah between these two. Okay. Okay, so then we do the two-way factorial ANOVA. Okay, two-way. Kat sini kita tambah. Kita tambah kat situ ada two-way, which is the two factor. Kita attach two growth pula. Perkembangan tools pula kat situ. So kat situ, kita tengok balik. Ni ialah yang kita buat tadi tu. This is how we visualizing the result. We combine it for this. And this is we separate it by using the dose, different dose. You can see the parallel for the line. And this is the two-way factorial ANOVA. In the two-way factorial ANOVA, subjects are assigned to group that are formed from the cross classification of two factor. Okay, this example use the tools growth dataset in the base installation to demonstrate a two-way between group ANOVA. Okay. 60 guinea pigs are randomly assigned to receive one of three level of ascorbic acid, which is the three level tu ialah 0.5, 1 or 2 milligram, and one of two delivery method, which is orange juice or vitamin C under the restriction. Each treatment combination has 10 guinea pigs. Okay, setiap satu tu ada 10 guinea pigs. Okay. Kat sini. This is the result. Okay. So the dependent variable sekarang ni ialah tools length. So sekarang lepas tu the following listing show the code for analysis. Okay. So sekarang kita tengok macam mana kita nak dapatkan ni. By using the two-way factorial. Jangan. Okay. So sekarang kita tengok kita punya R. Okay, so kita attach two scrolls tu tau. Kat sini. Bukan. Kita attach data two scrolls. Okay. Jadi lepas ni kita break lah rasanya dah macam dah banyak sangat dah rasanya. Kan? Ke nak lama lagi? So kita lepaskan dulu two-way ANOVA ni. Okay, so sekarang kita tambah factor dekat situ. Okay, so we attach two scrolls here. Run. Tapi kalau kita nak tengok kan, feed just now data liter, boleh tengok tengok kat sini liter punya data, weight, gestation time, number. And this is the data for feed yang kita namakan sebagai feed tadi tu. Boleh klik-klik tau kat tepi ni. You can explore the R after this. Then we go for our code just now. We attach the tools, rows and the table. And this is the table for supplement and dose. Just now, it mentioned that each group tu ada 10 punya ni kan? 10 guinea pig combination. Okay, under the restriction, each treatment combination has 10 guinea pigs. Okay, setiap treatment tu ada 10. Okay, so kat sini ialah 10. And this is the two screws. Nampak tak? This is the two screws. Nampak length supplement dia. Supplement dia ada apa? VC, jenis VC and OJ. This is for the OJ. And if we look at this data, we can simplify something, then we can summarize something by using aggregate. This is why we call aggregate function. We want to know the mean dia on each group tu. Okay, look at this. Okay, so kita tahu kat situ by using group 1, group 2, this is group 1, OJ 0.5, this is the X mean dia. And by using the standard deviation pula, yang ni. Okay. Then, bila we want to know our data, head dia untuk two screws ni, macam mana head dia? Kita tak nak tengok semua, kita nak tengok sikit je. So, it give the 6 awal, the first 6 kan? Okay, this is the supplement and this is the dose and this is the length just now ni. Apa dia? Aggregate length. Dose supplement and another one factor tu. Okay. Dan kat situ ni kita namakan aggregate ni lah sebenarnya. Okay, so then dekat situ apa yang kita tengok ialah view. Okay, we want to view the two screws. We run it. Function view tak ada. Okay, how can find function view? Couldn't find function view. Boleh kita install, kamu dapat tak? Dot package. Then ada, kamu ada? Sama ada nak letak dekat atas ke, nak letak kat bawah ke, sama je. Okay. Kalau ada masalah dekat situ, dia tak tahu kat mana, tak dapat. So then kita install package, view, then rasanya before we use it, okay. Saya tambahlah kat atas tu nanti bila kita nak gunakan. Okay, this is view. Then after that, we have to use the library view. Kan, that's not. Then install the package view. Mana? Then library view.
Doktor, nak tanya yang aggregate tu kan sebelum ni kita ada buat dua aggregate tu kan, yang mean dengan standard deviation tu. Kita kira mean of two scrolls tu ke?
Macam mana yang tadi tu? Yang ni aggregate ni.
Ni. Ni kan group 1, group 2. X tu two scrolls
Sebab tu.
Sebenarnya dia.
Okay, lepas tu? Tak, X tu ialah two scrolls punya mean.
Dia ambil two scrolls lah. Okay.
Lepas tu, kita ada apa lagi tu? Ni standard deviation dia.
Okay. Sebab dia dalam coding tu tak ada pula mention two scrolls tu. Tapi dia ambil sendiri kan.
Tak, bukan. Dia macam, kejap
Dia ambil len tu LEN tu
LEN tu.
length of two scrolls tu lah.
Length lah. Dia nak tahu length kan, impact of length daripada supplement and dose. Lepas tu kan kita kena cari length tu. Kan kita punya model tu nanti is length. Okay, supplements punya interaction dengan dose, adakah dia memberi impact dekat length tu? Macam tu.
Faham. Saya baru ternampak tadi yang kolom ni nama length. Okey. Saya dah
tadi
faham.
duk cari Afika. Saya tadi duk cari apa length ni. Saya dah macam lost. Kita makan kismis lah. Saya macam nak relate balik dengan yang mula-mula saya cakap tu kan. Okay. So kat sini ni length. Length ni ialah length of dia punya teeth tu kan. Okay. Sebab saya ada error dekat sini. Sekejap Error in view to stroke. Could not find view tadi tu. Sekejap Kita dah letak dah install that package view. Then to screws. View to screws. Couldn't find. Saya buat library tu tadi. Maksudnya to screws table. Okay. We want to know the interaction flow. Okay, mula-mula kita tak nak view dulu. Ni sebab dekat sini kita dah plot dah. Kita dah plot dah dia. Kejap saya komen dulu. This is the kita komen dulu. Okay, kita komen ni dulu sebab because of after we know the shape kita tadi kan. Shape kita ni, this is the length, this is the supplement that we use, this is the dose. And after that, we do the we want to know the length ni after our factor interaction between supplement and dose. Okay, then summary of this fit, you want to know the significant level dia kat situ. Nampak tak? It is significant. Less than 0.0. Okay. Different dia 111. Okay, so the table statement indicate that you have a balanced design, equal same size in each cell of the design, and the aggregate statement provide the cell means and standard deviation. The ANOVA table provide the summary function indicates that the both main effect, supplement and dose, and the supplement interaction with dose are significant. All these three punya factor ni semua significant. Sebab kita tengok dekat p-value dia tu. Okay. Okay, then kalau kita nak tengok dia punya interaction plot dia between this supplement. Lepas tu dia nak draw dekat situ tu ialah dose dengan pin of length dia punya tu. Okay, kejap kita tengok. Right. Okay, dia punya visualization. This is our supplement. Supplement apa? Saya nak nampakkan yang tepi ni. Okay. Okay, the plot provide the mean dose length for each supplement of each dosage. Kat sini each dosage and this is mean of length dia. Then with a little fineness, you can get an interaction plot out of the plot mean function G plot PQ. Okay, so sekarang kita nak tengok dia punya plot means. Okay, so sekarang this is the interaction between these two plot between the for the different supplement. Okay. How we visualize it? This is the interaction plot yang dia bagi kat sini. Then here we want to do the G plot. Okay, G plot yang ni. Apa yang G plot ni bagi? Okay, this is the different sample just now. And this is the different supplement type tu kan. And this is the different dose. Dia bagi kat situ. Okay. The graph includes the mean as well as error bar. Okay. And this is 95 with 95% significant level interval. Okay. Confidence and sample size. Okay. Then finally you can use the interaction to WT from the HH package to produce a plot of Postman effect of two variable of figure 9. Macam mana kita nak tahu dia punya two-way interaction for factorial design of any order. Okay, so kita boleh guna ni HH punya library. Macam mana interaction dia. Okay, this is the library HH. And this is the interaction. That's me. Okay, two-way interaction. Okay, so this is from the different dose. And biru ni is from the dose 0.5 and this is supplement per dose kan. Okay, this is the model dia daripada supplement per dose. And this is the from supplement daripada supplement yang berbeza. And this is from the length dia daripada dose yang berbeza. And this is per dose per supplement kalau kita nak satukan semua punya faktor ni dalam satu graph. Okay. So. Okay, this figure has been modified to display more clearly in black and white and will look slightly different when you run the code yourself. All three graphs indicate the two growth increase with the dose of absorbic acid for both orange juice vitamin C for 0.5 and 1 milligram dose. Orange juice produce more sucrose than vitamin C. Orange juice, Orange juice produce more sucrose compared to vitamin C. For 2 milligram of absorbic acid, 2 milligram yang ke atas ni, okay, both delivery method produce identical cross. Okay, untuk 2 milligram. Okay, untuk 2 milligram tu dia punya tu is identical cross of the 3 protein method provided. Okay. Okay, this is how we want to know the effect. This is the effect by using the dose yang berbeza menggunakan dua suplemen yang berbeza. Ni macam mana kita nak visualize our data. If we have the different type of data and we have the different factor and we also have the level tu berbeza, covariate ada kat situ by using the different supplement and different dose level, and we can use this visualization to visualize all of them. Okay. This is, lepas tu kita nak masuk yang ni. This is the interaction just now, and this is how we can conclude our effect tu dengan menggunakan table yang berbeza inside one display macam tu. So we can explain. And this is the what we can conclude from this graph yang saya cakap tadi lah. Okay. And this is for repeated measure ANOVA. Okay, untuk repeated measure ANOVA, kalau kita reflect back apa yang kita belajar tadi, ialah kita buat benda yang sama tetapi kita macam ulang lagi menggunakan measure, contohnya kita gunakan yang tadi tu, dia ulang lagi tapi dia gunakan test yang berbeza. Okay, in repeated measure ANOVA, subject measure more than once. Okay, maksudnya kita measure, contohnya sebelum tu kita guna pada 5 minggu, then we measure again after 6 months. Okay, this section focus on repeated measure ANOVA with one within group and one between group factor. Okay, we'll take our example from field of psychology, ecology. Physical ecology study how to physically and biochemical process of living system. Okay, maksudnya macam ni lah. Kalau macam contohnya ekologi kan, kita nak tahu dia impact tu, kita tahu, kita macam contoh, we have the impact of pembangunan ni, kita tak buat sekali. Kita akan buat measurement tu repeated. After 1 year of this pembangunan, kita nak tengok impact dia. Then after 3 years, we want to know the impact of the, contohnya penebangan hutan ke. Okay, this is what we call repeated. Repeated measure. Measurement yang sama but we do it more than once. Okay, a crucial area of study given the realities of global warming. Contohnya kat situ lah kita nak tengok kesan kepada global warming ni, kita tak buat sekali je. We have to do it continuously. Okay. Then I think the repeated measure ANOVA ni kita sambung pukul 2 dah, betul tak?
Betul, Doktor.
Betul kan?
Saya setuju.
Saya pun setuju. Sebab dah penat cakap. Banyak. Kalau boleh bagi latihan ni, kalau macam kita masuk in our class linear algebra ke, saya dah bagi tutorial. Okay, buat dulu, nanti kita bincang. Ini kita macam tak boleh because we have to stick with our data. Bila kita stick dengan our data tu, baru kita nampak perbezaan dia lepas kita tambah covariate. Macam tu kan? Okay, so we stop at slide 60. Then we continue on 2 o'clock lah, kita 12, 1, 2. Boleh? Is it okay? Okay, so we continue on 2 o'clock. So I stop this recorded, then after this I'll put in the ULearn. We have for this today class, we have part 1 which is the morning session, and the part 2 is the after lunch session punya part. Saya letak 2 nanti. Okay, stop my Webex session. Then we will